So continuing with S block elements, let us do some more important questions. First question in this lecture is comment upon basic character of oxides. Sorry, upon basic characters of oxides and hydroxides of group 2 element. The basic character of hydroxides and oxides of group 2 element that increases from top to bottom, it is due to decrease in strength of the metal oxygen bond when we move top to bottom. Beryllium oxide, it has the maximum strength of the beryllium and oxygen bond, that's why it acts as a amphoteric oxide. Then we have the next question, comment upon the halides of group 2 elements. All the elements of group 2 they form divalent hydrides. For example, we have CaCl2, BeCl2, MgCl2, SrCl2, BaCl2, etc. The oxides of beryllium they exist in the monomeric form, they exist in the dimeric form, they exist in the polymeric form. This is dimer, this is monomer, and this is polymer of BeCl2. The other halide they have ionic character due to their larger sizes. Then we have a question, comment upon the stability of sulfates of group 2 element. The sulfates of alkaline earth metal they are quite stable, but on heating at very high temperature they decompose to give metal oxide, sulfur dioxide and oxygen. Then we have the question, comment upon the stability of carbonates. The stability of carbonates also increases top to bottom, but they are less stable as compared to sulfate due to least and less lattice energy. They on heating decompose to give metal oxide and carbon dioxide. Then we have very important question, right? Anomalous features of beryllium. We have 5 common features. They have small size, high ionization energy, high melting and boiling point due to covalent network, absence of vacant d orbital, its oxides are amphoteric, due to small size of beryllium. So these are the few characteristics of beryllium which are very peculiar characteristics on the part of beryllium. It does not give color to the flame due to its small size and high ionization energy. It is not capable of exciting electrons of the valence shell. Then we have the question, what is diagonal relationship? The elements of second period and third period which are placed diagonally, they show resemblance in properties. This relationship is called a diagonal relationship, which can be defined as, so this is question number 4, what is diagonal relationship? Give its cause and discuss it in beryllium and magnesium. Diagonal relationship, it is defined as the lithium and magnesium will be discussing. Diagonal relationship, it is defined as the resemblance in the properties of a particular group of the second period and an element of the next group of the third period, or the elements of second and third period which are placed diagonally. They show resemblance in their properties. This is called as diagonal relationship. The cause of diagonal relationship is when we move diagonally, this is the element of second period, then we have the elements of third period. Lithium resembles with magnesium, beryllium resembles with aluminium, boron resembles with silicon. So this is diagonal relationship, this we are discussing now. So lithium and magnesium, they show diagonal relationship. The important points of their diagonal relationship: both metals are quite hard, they have high melting and boiling points, both possess high melting points, and they react with nitrogen to give nitrides. They are carbonate, hydroxides and nitrates. They are less stable, they decompose on heating, and on heating with oxygen they produce oxides. The oxides get deposited on their surface and tarnishing their surface. The hydroxides of both the elements, they are less stable, hydrides are less stable, they decompose on heating, and these both metals, they have weak basic character of their hydroxides. Then we have give preparation of quicklime. It can be prepared by decomposing CaCO3, heating it at 1270 Kelvin. This is our quicklime. It is used in the preparation of cement, it is used in the whitewashing, and large number of compounds are prepared from this metal. Then we have the next, give preparation and uses of the compound milk of calcium. What is milk of calcium? Also, milk of calcium is CaOH twice. Preparation is done from quicklime mixed with water to give you CaOH twice. Uses, it is used in medicine under the name Dizene. It is used in whitewashing. Then what is milk of magnesia? Milk of magnesia is MgOH twice. Its preparation is similar to milk of calcium, MgO mixed with water to give you MgOH twice. It is also used in the medicines like Dizene to remove the acidity of the stomach. Then we have calcium carbonate. Calcium carbonate can be prepared preparation can be done from quicklime by passing carbon dioxide through lime water. This is your calcium carbonate. It is also called as limestone. Uses, it is mainly used in the preparation of building material like cement. What happens when magnesium is burnt in air? When magnesium is burnt in air, it combines with nitrogen and oxygen of the air, producing Mg3N2 magnesium nitride and MgO magnesium oxide. Then we have LiF is insoluble in water. Why it is insoluble in water? The reason for this is LIF has high lattice energy, due to which it is not able to dissolve in water. Water is not able to break the lattice of the LIF. Then we have the very important question, why LiCl acquires covalent character but NaCl is ionic. It is due to high polarizing power of lithium cation. It polarizes the electrons of chloride ion and acquires an homogeneous distribution of the electronic cloud of Cl above it, and it converts the LiCl into a covalent compound. While in case of the sodium ion, the size of sodium ion is quite large. They are having less polarizing power. That's why NaCl bond is not able to acquire covalent character. Then why MgOH twice is a weaker base than NaOH? The reason for this is the MgOH twice has small size of magnesium. It has strong bond with OH, therefore OH ion cannot be produced in the acidic medium by MgOH twice, while in NaOH the size of sodium is quite large and its bond with OH is quite weak. It has ionic character, therefore in aqueous solution NaOH ionizes to give OH ion. That's why NaOH is a stronger base as compared to MgOH twice. Now, very important question from this unit is what is cement, how it is prepared, and what do you mean by setting of cement. What is cement? Give its composition, preparation. As we know, cement is finely powdered mixture of calcium silicates, calcium aluminates, calcium ferrates. Along with that, it contains some other salts like calcium, sodium ferrate, calcium aluminous ferrate, etc. Now, cement contains two types of material. Number one is calcareous material. These are the materials which supply calcium. CaO. It is 50 to 60% used in the preparation of cement. Then we have argillaceous material. They do not contain calcium. For example, SiO2, it is in cement, it is 25% by percentage. Then we have some other materials like we have the Na2O, we have CaO, we have Na2O, K2O, they are 1.5%, 1.5%, we have SO3, 1.5%, we have Fe2O3, 2 to 3%. So this is the way how different materials they are used in the preparation of cement. All these calcareous and argillaceous material, they are mixed together and they are changed into the slurry by mixing them with water. The slurry is introduced from the top of cement kiln. Cement kiln is a structure like this. This is the upper part of the kiln, where temperature is around about 800 to 1000 Kelvin. This is the middle part, where temperature is 1200 Kelvin. Then we have lower part, where temperature is more than 1200 Kelvin. So when argillaceous calcareous paste, that is slurry, is introduced from top of the kiln, First of all, it reaches in the upper part where all of the moisture it goes off. In the middle part, any lime added to preparation of cement, it decomposes to give you CaO plus CO2. CaO is mixed with silica to give you tricalcium silicate. It combines with alumina also to give you 4 calcium aluminate. It gets mixed with the calcium and iron oxide to give you 3 CaO Fe2O3. These are all called as cement clinkers. They are collected at the bottom of this furnace. From bottom they are taken out. These cement clinkers, they are crushed to the powder state and are mixed with 1 to 2% gypsum and color which is required, and then they are packed in the bags, and the cement bags are then sold in the market. So this is regarding the preparation of cement. Then we have what is global salt? Global salt is hydrated sodium sulfate having 10 water molecules. This is called as global salt. Then we have what is microcosmic salt. This is sodium, ammonium, hydrogen phosphate having water molecules. These are called as microcosmic salts, that is sodium, ammonium, hydrogen phosphate having 4 water molecules of hydration. Then what is sorrel cement? What is sorrel cement? It is mixture of MgCl2 and MgO. The mixture of MgCl2 and MgO is called as sorrel cement. It is used, its paste is used in the teeth work also. Then what is milk of magnesia? It is MgOS twice. What is cassiterite? Cassiterite is a ore of magnesium. Formula is MgSO4, single water molecule. Then what is the formula of calcite? Calcite is CaCO3. What is the formula of magnesite? It is MgCO3. Then we have the dolomite. What is the formula for dolomite? It is a combined ore of magnesium and calcium. Its formula is MgCO3 and CaCO3. Then we have the carnolite. It is a ore of potassium and magnesium. Formula is KCl, MgCl2 and 6 water molecules. What is the formula of gypsum? Gypsum is CaSO4, 2H2O. What is limestone? It is CaCO3. What is fluorspar? CaF2. What is your anhydrite? Anhydrite is CaSO4. Now what is quicklime? Quicklime is CaO. So these are the important questions for your unit S block elements. In the next lecture we will be taking P block elements. Thank you very much.